I'm so glad you could join me. This evening, I thought we could take another look at this amazing book from DK. If you'd like to check out the previous version, you can check out my universe list. This is the mysteries of the universe. It is a textured binding of dark blue or navy. There are gold embossed decorations on the front. Here we have the constellation Leo with the stars connected within the illustration of a lion. We have a comet, and then we have some galaxies in their spiral positions. We have exploding stars and planets like Saturn, maybe. We have asteroids and Mars. Maybe this one is Venus or one of the other planets. It's a good sized book. Let's read a little on the back. It's illustrated by Angela Reza and Daniel Long. Journey from Earth to the outer reaches of the universe, encountering peculiar planets, distant stars, and intricate galaxies along the way. This fascinating collection reveals the secrets behind more than 100 celestial objects, featuring astounding facts and exciting new scientific discoveries. Stunning photography, beautiful illustrations, and engaging stories shed light on the mysteries of space that have captured our imagination for centuries. And on the back, there are more embossed illustrations of asteroids and galaxies. The pillars of creation, Jupiter, the moon, a comet. Let's take a look inside. This book was written by Will Gator, illustrated by Angela Reza and Daniel Long, and it's a DK book. And I thought we would pick up where we left off, so we just went through all of the planets and a previously named planet, Pluto. We are in the Kuiper Belt, and this is an ancient icy objects slowly collided and squashed together. This peculiar-looking object is known as Arakoth. It lives in the outer solar system, inside the Kuiper Belt. Though it might not look it, it's actually one of the most exciting and important celestial objects that humans have ever visited with a space probe. What makes it so interesting is its great age. It's roughly 4.5 billion years old, and how well preserved it is after billions of years floating in the depths of space. It has survived untouched for all that time, so scientists hope studying it will tell us about how our planetary family formed. So as you can see, it looks very much like a snowman, and it even has these little depressions that kind of look like buttons. And you can see in the illustration over here, there's actually a rift and two depressions that look like a face. Comets. Some comets develop two tails, one made of gas and one made of dust. Comets are the frozen voyagers of the solar system. These lumps of dusty ice usually spend most of their lives in the outer parts of our cosmic neighborhood. Sometimes, though, their long arcing paths around the sun bring them close to the warmth of our star. As the comets heat up in the sunlight, some of the ice on its surface turns to gas, and it may also start releasing tiny grains of dust into space. When this happens, we can sometimes see the comet as a fuzzy patch in the night sky, or, if we're really lucky, a bright blurry light with a long glowing tail. This picture of Comet Hale-Bopp was taken in 1997. The blue streak is the gas tail. For those of you not old enough to remember the Hale-Bopp comet, there was quite a human reaction to seeing this comet. And you can look up the Hale-Bopp cult and see what happened to those poor, unfortunate people. Cliffs on a comet. On Comet 67P, also known as Churyumov-Gerasimenko, huge icy cliffs rise over a frozen landscape covered in boulders. The land is cracked and rugged, and scientists describe the texture of some areas as goosebumps and dinosaur eggs. There are giant pits where jets of gas and dust burst out into bright sunlight. We know all of this because a European spacecraft named Rosetta traveled to 67b and captured spectacular close-up pictures of its surface. While it circled the comet, Rosetta made important scientific discoveries. From the data it gathered, scientists are hoping to learn more about how comets could have helped to make planets like Earth. Some of the cliffs on Comet 67b are several hundred meters high. So here's a profile look at the edge of the comet. The Oort cloud. Some scientists think there could be well over 1 trillion objects in the Oort cloud. you know there's a feature of our planetary neighborhood that no one has ever seen? It's called the Oort cloud, but it's nothing like the fluffy white wisps that float across our blue skies. It's thought to be a huge swarm of comet-like objects that surrounds the solar system. It's incredibly far away. Parts of it are thousands of times farther from Earth than the most distant planet Neptune. So why do astronomers think the Oort cloud is out there if they've never actually seen it? One reason is that comets sometimes arrive in the inner solar system that seem to have come from this remote region. Scientists think there must be many more lurking out there to explain these well-traveled wanderers. Interstellar visitors. In the last few years, astronomers have come face to face with the first known visitors from distant star systems beyond the sun's realm. These two alien travelers weren't the kind you might imagine from sci-fi movies, though. Instead, they were an asteroid and a comet that must have been flung from the faraway home system long ago. The asteroid, called Oumuamua, was seen zipping through our solar system in 2017, while the comet Borisov was spotted in 2019. Astronomers raced to study the two interstellar objects before they zoomed away forever, in the hope of learning more about the mysterious places from which they came. So here's kind of a path of one of them around the sun and then back out. This lovely picture. NASA telescopes use infrared and X-ray light to reveal the beauty of the Milky Way. That's quite lovely, isn't it? We have dark blues and purples, and we have oranges and reds and yellows and pinks and white and blues. So beautiful with the filters. Scientists think the Milky Way contains around 125 billion stars. The Milky Way. Our sun is one of billions of stars that swirl through space in an enormous gathering known as a galaxy. We call this home galaxy of ours the Milky Way. That's because, from our perspective, sitting among this huge swarm of stars, the rest of the galaxy looks like a milky, misty ribbon of light. If you could fly away from the Milky Way and look back, you would see that the galaxy is shaped like a disk with a ball-shaped center. Within this disk, there are whirl-like structures called spiral arms. We live inside one of these. So here you have the center, and you have these spiral arms, and each one may contain different solar systems. So within our own galaxy, there may be many other solar system like ours. Stars. Every night the sky glitters with the light of countless twinkling stars. They appear as tiny points to us only because they are so far away. explore them up close, we'd see that they are, like our sun, blazing balls that shine as matter fuses or joins together inside them. Since the stars are so distant, it takes a long time for their light to reach us. For example, the light we see now from the middle star in Orion's belt, Alnilam, started its journey almost 2,000 years ago. When you look at the sparkling night sky, you're actually gazing deep into the past. Isn't that amazing? Stars can have lifespans of billions of years. This group of stars was photographed by the Hubble Space Telescope. You have this kind of cloudy area with groups of stars. Proxima Centauri. In 2016, astronomers discovered a planet orbiting Proxima Centauri, where the pale band of the Milky Way runs through the southern hemisphere constellation of Centaurus. The night sky is brimming with stars. Nestled among these gems is a faint red star called Proxima Centauri. Though you'd need a good telescope to see it, this little fleck of light is quite special. At about 4 light years away, Proxima Centauri is the closest star to the Sun. It is still a huge distance from us, though. If the Sun was the size of the tip of a pen, then Proxima Centauri would be nearly 18 miles, or 29 kilometers away. An illustration here that shows our Sun, the Oort cloud. This ring would be 2 light years away. This ring would be 4 light years away, where Proxima Centauri sits just outside of that. And then this outer ring would be 6 light years away. This image of Proxima Centauri was captured by the Hubble Space Telescope. Look at that, like a giant diamond in the sky. Pretty neat. The youngest stars. Enormous jets of material sometimes shoot out from protostars like beams from a lighthouse. Stars are born within enormous clouds of gas and dust floating in space. Astronomers think the process begins when clumps start to form deep inside the cold, dark haze. Over time, the clumps grow as they gather material from around them, a bit like how a snowball gets bigger. Eventually, a spinning object known as a protostar forms. If it grows large enough, nuclear reactions can fire up within a protostar's center, and it becomes a fully fledged, shining sun. Scientists still have a lot of questions about exactly how all this happens. This is partly because baby stars are often hidden by the dusty gas clouds in which they are born. To investigate, astronomers need special telescopes and cameras to peer through the murk. This protostar is gathering material from the gas surrounding it. You can see that. Pretty neat. What do you think is causing these swirling gas clouds to glow such a beautiful ruby red color? Look at the very center of the view where the clouds are brightest, and you'll see the culprits. A group of 4 sparkling newborn stars. This little collection is known as the Trapesium Cluster, and it lies nestled in the heart of the Orion Nebula. The stars in the trapezium are scorching hot, and they blaze brightly. Their light energizes the gas around them, causing it to give off a pinkish red glow. Curiosities like the Trapesium Cluster are fascinating to astronomers because by studying them we can learn more about the early lives of stars and the groups they form. You can spot the Trapesium Cluster from Earth using a small telescope. We see the dark around, and then this cloudy center. You can see some of the darker pinks out here. And then the closer you get to the center, the lighter it gets. And I think this might be Orion's belt right here. And then here you have those stars. The cluster in the middle. Star clusters. When you gaze up at the night sky, you'll see little groups of stars huddled together. Astronomers call these groups star clusters. Some of the easiest to see are open star clusters, collections of bright young stars that have formed together in space. The Pleiades is a famous open star cluster that sits in the constellation of Taurus, the bull. There are more than 1,200 infant stars in this dazzling crowd. Recent measurements suggest that the stars in the Pleiades are only around 130 million years old. Our sun probably formed within a cluster of stars that has now spread out across the Milky Way. Pleiades is also known as the Seven Sisters. Take Eda, Seleno, Electra, Merope, Alcyone, Maya, Asterope, and recently we went to a dark area and looked at these with our little telescope, and it is pretty amazing to see them all grouped together. Birth of a planet. How exactly do planets form? That is a question that has had scientists scratching their heads for centuries. To look for clues to this mystery, astronomers today use powerful telescopes to study newly formed stars, far beyond our own solar system. They do this because many of these distant young stars are surrounded by enormous circular clouds of dust and gas, called protoplanetary disks. Astronomers think that swirling inside these disks are the raw ingredients from which worlds can be made. So by examining them, we can learn more about how a planet is constructed. Scientists have already uncovered signs of planetary building blocks, such as small pebbles around some young stars. Billions of years ago, our sun was probably surrounded by a protoplanetary disk. This illustration shows a protoplanetary disk surrounding a young star. So you'd have the new star, and then this would be the protoplanetary disk. And it looks like there's just all kinds of debris and dust throughout. Exoplanets. So far, more than 4,000 exoplanets have been found orbiting around distant stars. These 3 exoplanets orbit GJ357, a red dwarf star. So you see they're kind of positioned as you would see Mercury and Venus and the Earth in our solar system. So here you have GJ357d, which would kind of be in the Earth's position, G1357c, which would be in Venus's position, and GJ357b, which would be in Mercury's position. While we don't know if there are other life forms elsewhere in the Milky Way, we do know that there are other planets out there, thousands of them in fact. These worlds are known as exoplanets. There's still a lot about exoplanets that we don't know. Many of them seem to be very strange places indeed. Some could have bubbling surfaces of molten rock, while others have ferocious winds that race around their atmosphere. Some are giant worlds made of gas that orbit close to their fiery parent star. We don't have anything like that in our solar system. In the coming decades, new telescopes should allow us to take a closer look at some of these faraway planets. Perhaps we'll even find one just like Earth. And that's what the James Webb Telescope is helping us do. Vega. The light we see today from Vega left the star's surface about 25 years ago. Sometimes my son and I talk about which of the stars we think may be already exhausted that we're just seeing now. Vega is one of the brightest stars in the night sky. It lies in the constellation Lyra, close to the rich star fields of the Milky Way. If you cast your eyes toward this brilliant star on a clear fall night in the northern hemisphere, you'll see it has a white hue with a slight hint of blue. Gaze around and you'll soon see stars of other colors too. Some orange, some yellow, others zingy blue. Why are stars different colors? It all depends on their temperature. The hotter a star is, the bluer and whiter its light. Cooler stars are more yellow and orange. Some of the coolest stars in the galaxy have a deep red-orange glow, like embers in a fireplace. Vega was the very first star after our own sun to be photographed in 1850. Well, that's interesting. So here it is. And this is the constellation Lyra. And there's Vega on that end, right there. Juice. One of the most mysterious stars in the constellation Orion is the red-hued Beetle Juice. It is in the very final stages of its life. After consuming much of its fuel, it is bloated to become a vast, red supergiant, measuring more than 746 million miles, or 1.2 billion kilometers across. If the Sun was the size of a pea, Betelgeuse would be over 23 feet or 7 meters wide. When it dies, Betelgeuse will likely explode as a brilliant supernova. Astronomers aren't sure exactly when this will happen, but some estimates suggest it could detonate in the next 100,000 years. You could squeeze about 900 trillion Earths inside Betelgeuse. So in the Orion constellation, the bottom, its belt, his bow, and then up here on the shoulder, you have Betelgeuse. Eda K Nebula surrounding Eda K Carina constellation. You wouldn't know it if you looked at the softly shimmering star fields in the constellation Carina, but this stretch of the southern hemisphere night sky is full of violent activity. Within Carina, there is an incredible stellar system called Eda K, which is composed of 2 stars. The reason it is so fascinating is that one of the pair has recently experienced unimaginably huge eruptions. Scientists think that it is probably close to the end of its life. Eda K is surrounded by a peanut-shaped cloud of material and glowing wisps of gas. These were probably created during previous explosions of the dying star. Eventually, Eda K will detonate in one final enormous explosion called a supernova. As it does, it will shoot material out into space that may one day form the beginnings of a new generation of stars. Eda K is so far away that the events we see today actually happened over 8,400 years ago. Isn't that fascinating? That something can be so long ago and we're still seeing it now. Eda K exploded several times in the 19th century. So here we have what it looks like. The explosions emanating gases and debris. It's beautiful. Supernova. The most famous supernova of recent times, SN 1987A, occurred within a nearby galaxy in 1987. Sometimes a star can explode in a violent blast that astronomers call a supernova. These spectacular events can occur in different ways. One type of supernova happens when a massive star gets old and runs out of the fuel that keeps it shining. When this happens, its center implodes or explodes inward, producing an explosion that destroys the star. Another kind of supernova occurs when the core of a long-dead star, known as a white dwarf, rips chunks of the atmosphere from a nearby star. If the white dwarf pulls enough material onto itself, it can explode, creating an enormous stellar firework that can be seen across huge cosmic distances. The colors in this picture highlight the shockwave and dust ring in the aftermath of SN 1987A. That is extremely fascinating. Look how beautiful it is. You have a dark pink and purple outer ring. Then you have these green orbs in a ring as well. Then you have dark reds that fade into oranges so that it's very light orange in the center. It's pretty amazing. Neutron star. Neutron stars are typically only about 12 miles or 20 kilometers in diameter. Neutron stars are the zombies of interstellar space. These amazing objects are created in the fiery explosion that occurs at the end of a massive star's life. Neutron stars are made up of a superdense material consisting of tiny subatomic particles called neutrons. A grain of sand-sized fleck of neutron star matter would weigh roughly 550,000 tons, or 500 million kilograms, about the same as 1,500 jumbo jets put together. Some neutron stars blast beams of radio waves out across space. If the beams pass over Earth as the neutron star spins, we can detect a throbbing radio signal. Astronomers call these objects pulsars. So here's what it would look like, a neutron star, and then these magnetic field lines around it. So in this photograph, this white cloud area. And you have these stars. And it says the neutron star is the one on the right. So you can see the magnetic fields outside of it. Black hole. Black holes are among the most mysterious objects in the universe. It's impossible to see them directly, and even the world's smartest scientists do not understand exactly how they work. What we do know is that black holes are an example of nature behaving very strangely indeed. These curious spherical regions warp the space around them dramatically. They have such a strong gravitational pull that even the fastest thing we know of, light itself, is dragged into them. This means they're almost totally black. Some black holes are thought to be born in the explosion that happens when a very massive star dies. There are even bulkier black holes hiding in the hearts of many galaxies too. Even our own Milky Way has one. The galaxy M87 has an enormous black hole at its center, with a mass 6.5 billion times the mass of our Sun. This image is our best ever view of a black hole's surroundings. Fuzzy ring around it. Globular cluster. Where do you think you can see the most breathtaking view of the stars? Looking up at a cloudless desert sky, perhaps, or far out at sea on the very blackest of nights? The answer, in fact, is not on Earth at all. It's the view from inside a globular cluster. These extraordinary objects contain thousands upon thousands of dazzling stars, all packed tightly together in the shape of a ball. Some of the Milky Way's globular clusters could be leftovers from smaller galaxies that were gobbled up by our galaxy a long time ago. If there are any planets orbiting the stars within these globular clusters, their night skies will surely be awe-inspiring, with countless brilliant points of light filling almost every patch of darkness. The globular cluster Omega Centauri contains at least 1.7 million stars. So here we have a large photo of that cluster. Look at all those stars. So many. Nebula. If you were to zoom across the Milky Way in a spaceship, you wouldn't just encounter stars and planets along the way. You'd also pass gigantic clouds of dust and gas that are scattered all throughout the galaxy. Astronomers have a name for a cosmic cloud like this. It's called a nebula, and there are several different kinds. Some, for example, are places where stars are being born, and where gas mingles with blazing new suns to create spectacular glowing shapes. Others are the ghosts of long-dead stars, shining ripples of gas that mark where a star once exploded. With powerful telescopes, astronomers can study these stunning forms, even in distant galaxies far beyond our own. The Carina Nebula in the southern hemisphere is so bright you can see it without a telescope. From top we have the Witch Head. Okay, I see it. So you have this view of stars, and the cluster is here. And if you follow, it would be looking at the profile, the witch's forehead, and the nose sticking out, and the mouth, and the chin. That's pretty funny. Then you have the Pipe Nebula. So I guess that looks like a pipe to some people. The Lagoon Nebula. That one's beautiful. I'm guessing the lagoon comes from this absolutely beautiful teal green color in the center. And then the dark coast around it. There's yellow and orange fading into purples and blues. It's beautiful. The Crab supernova remnant here. Lots of yellows and oranges and reds. And then the center is white with some blues and pinks and reds. And then we have the Necklace Nebula, because it looks like there's shining gems strung on an invisible chain. Green and blue. Beautiful. Emission Nebula. The striking reddish-pink color of an emission nebula comes mostly from glowing hydrogen gas. The Lagoon Nebula, which we looked at on the previous page, sits within the constellation Sagittarius. So how stunning is this? You have the dark background, stars, and then you have this cloud of red and pink gases. And the closer you get to the center, the lighter it gets, till you're into light pink and pastels and white stars. Have you noticed that a lot of pictures of the night sky in distant galaxies show splashes of bright pink and red? Each one is a glimmering gas cloud that astronomers call an emission nebula. Some stargazers refer to them as stellar nurseries because they are regions where new stars are forming inside vast swirls of gas and dust. An emission nebula gives off its colorful glow because the gases inside are energized by light from hot, young stars that have been born within the cloud. Pick up a good pair of binoculars, and on certain nights you can probably see an emission nebula for yourself. Planetary Nebula. Imagine you are out on a clear night peering at the stars through a telescope eyepiece and you stumbled across a sight like this. What would you say it looked like? To some of the astronomers who first saw these distant celestial objects, the rounded glowing gas clouds resembled faraway planets, so they became known as planetary nebula. In fact, they've got nothing to do with planets at all. A planetary nebula is what bursts into being at the end of some stars' lives. Each nebula you see here was produced when a star, probably quite similar to our sun, grew old and shed its atmosphere. As the star's bulk puffed out into space, its searing core was revealed. This core still glows today, and it pumps energy into the star's jettisoned atmosphere, making it shine in all kinds of fantastic colors. The Ring Nebula is about 6.2 trillion miles, or 10 trillion kilometers across. It's quite beautiful. The blue center, the dark blue. Then you have kind of this cerulean edge, and teal, and green, and yellow, and orange, and red. Could be called Rainbow Nebula too, couldn't it? The Southern Owl Nebula. It's quite pretty. Blues and whites. It has this pinkish red edge to it. And here you have the Blinking Nebula. Kind of an eye-shaped nebula. In the center green with a white pupil. Some red on each end. And then the Cat's Eye Nebula. This one's pretty fascinating. With a dark outer. You have some red here. And then you have these almost figure-8 looking pinkish rimmed areas. And then the center is a blue iris with the white pupil. I hope you've enjoyed this journey into the mysteries of the universe. I always enjoy